Hello everyone, Tom from everystepcalculus.com and everystepphysics.com. I'm going to do a related rates problem for Calculus 1 regarding a cone and its volume. And this is off of Yahoo. This is a person that was panicked because he couldn't do the problem correctly. And if he had my program, there would have been no problem. Let's get started. Index 8 to get to the menu. I'm going to press number 2 here for average rate of change. You can scroll down for related rates, whatever triggers your mind in that area. I always use the letters beforehand. Here we have, the numbers before the choices. Like this is number 3 for the cone and volume. I'm going to press number 3 here. And this is the formula for the volume of a cone. They give you the volume change, which is dV dt. So we're going to press alpha. You have to press alpha before you enter anything into these entry lines here. Alpha 5. And they give it as meters, number 3. And they give it as minutes, number 2. And it's increasing. So I always show you what you've entered, 5 cubic meters per minute. You change it if you want. I say it's number 1 is good. These are choices in the cones. They seem to be tricking you or giving you these different heights and radiuses for you to figure out, which really is the trick in cones. Throws everybody off. In this case, the height is equal to 3/4 of the radius, so I have a fraction here, 3/4 of radius. We'll choose number 1. I'm going to put alpha and then 3 divided by 4. And you'll notice that the height was equal to 3/4 r, so they've slipped that in here for number h, or letter h, for the height, and it turns out to be 1/4 pi r cubed. Alpha for the entering the height for the radius, where you're going to change the radius. Remember, the radius before what we found is generally for a full cone, and this is for the cone that's given for 10 meters high. So we're going to put alpha 10. Now notice that I didn't press alpha right, so I'm going to go back and change it. Alpha 10. That's better. Okay. Now notice the height is 3/4 of the radius. Well, that height equals 10 meters. 10 equals 3/4 radius, so then it's figured out through algebra and becomes 40/3 meters for the radius. So we have the original formula. We're going to take the derivative with respect to t on both sides. That becomes dV dt and equals 1/4 pi 3r squared. Notice that the derivative of r cubed is 3r squared. And that equals 3/4 pi r squared dr dt on the other side. Now notice they gave us 5 for the change in volume, so 5 is equal to this, and then we start doing the calculations. Dr dt equals 5/40 pi. The answer is 0.01194. Now let's see. You'll notice that the guy had, or gal had, this correct answer, meters per minute, but the book says it was for seconds. So anyways, that would be this divided by 60 per second, so the real answer is 1.2, basically 2 times e to the minus 4 meters per second. Pretty neat, huh? Everystepcalculus.com. Go to my site and buy my program, pass your calculus class. And don't forget to subscribe to my channel so you can see future videos or blogs.